So I just started the recording, and welcome to the GMAT Prep Hour. All right. Okay. All right. Welcome, and all is well. What we're going to do now is maybe talk a little bit about critical reasoning. All right. I think this is, after sentence correction, I think this is really the linchpin for getting that really high verbal score. Some of you may have wondered, has anyone felt like, gee, my verbal score is okay, but why can't I get that 41? There's like 51 points available, and here I am stuck in the mid 30s or the high 30s. Anybody felt like that? Why am I stuck in the 30s when that darn thing, that darn verbal score goes up to 51? Any of you having that experience? You can tell me no. Yeah, okay. So let's talk about critical reasoning. And one of the things that's interesting, now I'm going to try a screen share with you guys so that you can see a problem that I'm looking at. So, you're going to have to tell me, did I get it to work? All right, so here I go. I'm sharing my screen. Okay, I'm hoping this works. Can you guys see my share? Maybe I'll put a note on it. I'll put a smiley face. Can you see the problem that I'm sharing? Let me know. Okay. Oh boy, where is my chat window? All right, I got my chat window back. So can you guys all see it? Yeah, so I've got a problem up here. Okay, so often we think about critical reasoning in a really mechanical way. We tend to think that there's some magic formula that'll get us there. And really, the big secret to doing well in critical reasoning is spending more time understanding and reading the problem and figuring out the logic before you look at the answer choices. The answer choices are really, I would say designed to deceive you. That's how I feel. All right. And so, focus here. Okay. What do you guys usually read first? Do you read the question or do you read the argument? Let me know in chat. Question or argument? Good. Good, good, good. Yeah, the question first because the question frames your thinking. All right. So if I look at this, which of the following, if true, most seriously undermines the force of the evidence given as support for the hypothesis that endorphins promote longevity? What is this? What type? Those of you who've taken a Manhattan course will recognize the type. Yeah, it's a weaken. And weakens are one of the most commonly missed. Okay, so typically what we're doing, it's good, we're going to do kind of the 360 level view. We're finding with a weaken something else, okay, that explains the premise, some other reason why it might be happening. All right, so people who do regular volunteer work tend to live longer on average than people who do not. It has been found that doing good, a category that certainly includes volunteer work, releases endorphins, the brain's natural opiates, which induce in people a feeling of well-being. So what did that say in just simple English? Anyone want to just paraphrase that? What did it say? I mean, the language is a little awkward, but the meaning does come through. What did it say? Do good, get high. Oh, yeah, I love it. Do good, get high. I love it. I've got to give you a high five for that. That was awesome. What did the rest of you think? Do good, get high. Okay. Clearly there's a connection. Regular releases of endorphins must in some way help to extend people's lives. All right. And why do we believe this? Because the people who do good live longer. Okay, and they live longer. So this is a little odd. they live longer. And we know that doing good causes you to sort of get high, right? Doing good causes the feeling of well-being. Ooh, wait a second. Does anyone, yeah, but look back at it. There's a little disconnect here in this argument. Does anybody see a little disconnect? All right, the second sentence is definitely, you know, the release of endorphins causes people to get high, for sure, and doing good is something that releases endorphins. But what's different in the first sentence? There's something subtle that they're hoping that you're not noticing. All right. Look, Gloria, really closely. Do they tell you that release of endorphins helps people live longer? Is it there? Is it actually there? Look at that again. Just be really specific. No, as Sean is saying, no. But they want you to think it's there, but it's not there, okay? We know that people who do the volunteer work tend to live longer on average. And then there's this discussion of volunteer work causes endorphins. So we think that it must be the endorphins extending people's lives. All right, so you might want to pause and think for a moment. Could you break this argument? What might break this argument? Before you look at answer choices, what might break this argument? Other things that let people live longer, okay. Yeah, maybe they're not living longer because of the endorphins from doing good. All right. So now let's look at the answer choices and see what we can eliminate. All right. Now that we really understand it, we've thought, there's kind of a hole in it. It never says that the endorphins cause people to live longer. It's just that's the conclusion, but we don't have proof here. All right. It just says this. How did they get from here to here? Okay, so what can we eliminate? Maybe not alone. Yeah, what can we eliminate? What isn't relevant to this? You know, we've got this thing of endorphins promote longevity. What can we eliminate? E, releases of endorphins are responsible for a sense of well-being experienced by many long-distance runners. Yeah, this is not relevant. Okay. Not relevant. We're not talking about long-distance runners. Volunteers. So C, there are many people who have done some volunteer work, but who do not do such work regularly. The issue here, who's it about? Who's it about? What kind of people is this about? Notice this. This is something where there's a clue here, regular volunteer work. It's not relevant to people who do occasional volunteer work. They're saying regular volunteer work. All right, what else? Maybe, you know, relevant to that do good, get high thing about the endorphins getting you high. Because you might think, oh, what else might happen? Yes, if you're too high, you might walk off a cliff or something, right? Never reached as a result of natural release of endorphins. We're talking about endorphins promoting longevity. We don't need to worry about this. Okay. So now we're down to A and D. All right. Looking between the two, people who do regular volunteer work are only somewhat more likely than others to characterize the work they do for a living as doing good. And people tend not to become involved in regular volunteer work unless they are healthy and energetic to begin with. What's the answer? Yeah. Thanks, Mike. Yeah. D. Yeah. Why D? Why is D the answer? Why does D weaken? All right. Why does it weaken? Yeah, it breaks the premise. It breaks this idea. We're trying to show that the endorphins help people live longer. The author's trying to show that. Um, correlation, yeah, not causation. We've got this, well, the only people who are tending to do the volunteer work are healthy and energetic. Oh, that's another reason why people might live longer, that they're healthy and energetic to begin with. It might not be the endorphins from the volunteer work. It might be that healthy and energetic people tend to both live longer and do more volunteer work. So the causality is messed up. All right. Fantastic. So how did that one feel, thinking about it that way, thinking about it just a little differently? I'm going to pause my share. All right. And let's see, I want to get to maybe I need to stop it for a moment. Whoa. So, and again, guys, I'm just getting used to my new technology. How did that feel to do it that way, to really rely on understanding rather than any tricks? What did you think? Is that different than what you've done? Let me know in chat. Different or pretty similar? All right, let's see my new message. You don't read the question. Yeah, that causes a lot of the errors. Do you feel tense when you see a critical reasoning? Okay, a lot of people feel tense when they see critical reasoning. And one thing to do is to remember that if you really understand it, and you know the goal of the GMAT, okay, you're going to be able to solve the problem. All right. I'd like to do another one with you guys. This one's an evaluate, sort of a combination of a strengthen and a weaken. And the reading has some really interesting features. All right, I want you to read the question and then read the argument without looking at the answer choices and note anything interesting. All right, this time we're gonna, talk about it a little, and then we'll do the same thing, going through looking at the answers and looking how reading the argument closely helps us to more easily eliminate answers. Okay, so here goes my screen share again. All right, and here are my problems. Okay, so hopefully everybody can now see, I'm really hoping, a new critical reasoning problem. So can you see it? All right, now let's look at this one. Okay, and what you should do on the GMAT is take about a minute to read. If you read in a careful, relaxed sort of way, just thinking, what's it saying, getting to meaning, you're going to be able to solve. So which of the following would be most useful to determine in order to evaluate the argument? All right, this thing is clearly an evaluate. It said so. That was not hard. Okay, so what's interesting as we read this? Pay really close attention to the wording and the meaning. The growing popularity of computer-based activities was widely expected to result in a decline in television viewing, since it had been assumed that people lack sufficient free time to maintain television viewing levels while spending increasing amounts of free time on the computer. That assumption, however, is evidently false. In a recent Mail survey concerning media use, a very large majority of respondents who report increasing time spent per week using computers report no change in time spent watching television. Now, what's really interesting, did anything stand out as I read that? Okay, and just don't look at the answers yet. Really think, is there anything interesting here? There's something that just jumped out at me. Okay, so you were thinking about the survey at the end, William? All right, anyone else? Thinking about that survey, wondering about its scientific validity perhaps, or its sampling validity? I teach statistics by day. Okay, anyone else see something? I'm after something pretty simple. Computer can be used for non-free time. Okay, Braca. People in the survey are reviewing themselves, right? It's self-reported. Okay. But look at this. All right. I want you guys, did anybody notice the initial assumptions? Yeah, look at this. That assumption, however, is evidently false. And then look at the was widely expected, had been assumed. What about was widely expected and has been assumed? What does that foreshadow? If you see that kind of language in the past, it was widely expected. It had been assumed. If an academic is telling you that something was widely expected and had been assumed, what should you expect? Didn't play out. Yes, Daniel. It is not, right? Pay really close attention. Counter argument, counter assumption. Yes, Gloria. Okay. Now, this other thing here, that assumption, however, is evidently false, is very important as well. This is a clear statement of what I think of, and you see this in reading comprehension as well. Other people are wrong, all right? And this is a common thing to find in an academic paper. And all these arguments are drawn from academic writing. So other people are wrong. As soon as you're told that other people are wrong, what do you expect? I mean, Gloria identified it as a counter. And it is in Manhattan Prep's language. We had a counter, was widely expected, had been assumed, and now the author is saying, but those people are wrong. All right. What do you expect once the author tells you that other people are wrong? What should come next? I tell you what the other people believe, and then I tell you that they're wrong. What should I do? Okay. The author could share what is correct. Absolutely. What else? State why it is wrong. Yeah. So the GMAT is usually pretty simplistic. All right. So one thing that we're always looking for with these evidence family questions is the conclusion, because the conclusion puts the whole argument in perspective. And whenever you see one of these other people are wrong statements, you've gotten quickly to the conclusion. This is the author's conclusion. Those other fools are wrong. Okay. And then you have evidence. All right. So if you want to evaluate the argument, you've got to come up with something that speaks to the link, all right, between the evidence and the conclusion. Okay. That speaks to the link between the evidence and the conclusion. Okay, so we've got this evidence in a recent Mail survey concerning media use. A very large majority of respondents who report increasing time spent per week using computers report no change in time spent watching TV. Okay. All right, so how would we look at this? Is there anything, it was widely expected, that assumption's false. What do we know at this point? All right, is there anything that we can eliminate? Or is there anything that might help, that won't help us to evaluate? Now, if something will help us to evaluate, it won't make any difference either way. Okay. Gloria is saying A, whether a large majority of survey respondents reported watching television regularly. And William is saying D. All right, Eshan, you're saying C. Okay. All right, so now I'm going to ask you C, B, D. All right. Ooh, look at this. Answer is E. Yeah. Why? What's the key? There's something in the argument that makes me suspicious of E as well. What did they say? All right, what did the GMAT say? Where is it? There are a couple of words in the argument that should make me think that it's probably E. Free time. You got it. Free time. Okay, this pertained to free time. So if they're working, all right, on the computer, then they're not spending their free time on the computer. Okay. Notice this detail stuck in there. GMAT does this over and over again. All right. A detail will be hidden in there that makes it much easier to solve the problem. All right. So questions from this one, any questions or comments? I feel like I should do a couple of math problems for the people who wanted quant. But let me just stop sharing this so I can go to my math deck. And you guys tell me, all right, anything interesting doing it this way? You saw this one before? Okay, yeah, if you've seen the problem before, it definitely helps. It is in the class slides, but the answers aren't in the class slides. Can I please explain why it's E? All right, because if I look at the problem, and here, let me bring it back on share. Okay. Okay, so if I look at this problem, it's talking about free time. All these assumptions are about, or this assumption is about free time. Let me get my annotation pen here. People lack free time to maintain their TV viewing habits if they spend their free time on the computer. Okay, the author screams at us that assumption, however, is evidently false. Other people are wrong. All right, and that's our conclusion. Because of this survey, where a large majority of respondents who report increasing time per week spent using computers report no change in time spent watching television. So notice how here it says time, not free time. All right, not free time. A very subtle shift. Okay. All right, so if you look at these other answers, they're decoys. People who rarely or never use computers, that's not what it's about. All right, it's computer-based activities. This doesn't rule out work. Okay. Was widely expected to result in a lack of free time. All right. TV programs changing. It's not about different programs. It's about total time spent. Okay. And then we're talking about people already who report increasing time spent per week on computers. Okay. We don't really care whether they're the owners or not. It's just people who use computers. A large majority of survey respondents reported watching television regularly. Well, you know, it says a large majority of the respondents who report increasing time spent per week report no change in time spent watching television. What are we interested in? We're interested in the people who are using computers a lot. all right, their television viewing habits. So this doesn't matter as much. Whereas when we look at E, all right, computers at work. Here's the little stealth thing. Okay, oh, the time could be spent on the computers at work. All right, did that help? Evaluate is a specific type of CR question. Yeah, evaluate. And after weekends, I would say, you're welcome. Evaluate is one of the ones that people get wrong the most often. And yes, you know, the brute force logic does help recognizing the conclusion, but also these little details. Oh, free time versus work time. Hey, wait a second. Why did they change it? They're up to something. Okay. And that's really helpful. You're welcome. You're welcome. Hopefully this was a good thing to do. Can I stop the share now? You guys want to see a quant problem? Can I go for something in quant? Okay. All right, I'm going to stop the share. Okay, so hopefully that's stopped and you can now see my face, big video of me. All right. And let's see, let's look at something. Oh, let's see, what do I have that people find particularly annoying? And I had a note on exponent problems and I had a note on, okay, so let's look at something that might be a little bit annoying in an exponent problem. All right, let's see. Okay, here we go. Here's something that might be a little bit annoying. And it's a data sufficiency. I'm going to just share this screen. Hopefully this will also work. Okay, and I can't. There we go. All right, can you guys see the exponent problem? Can you guys see it? Let me know. Here, let me bring my chat up again. Okay. Now, as you look at this, one of the things we want to do with exponent problems is right away apply exponent rules to make them easier to deal with. All right. But in order to make them easier to deal with, again, you have to read the whole problem, including the statements before you do anything. Do any of you rush? You're just reading the problem. I mean, and it's worse with a long word problem and you're starting to do it before you've really read everything. Any of you tend to rush a little bit? Yeah, we'll go to something where it's harder, okay? I think maybe tonight's theme is how do I patiently read the whole thing and increase my odds of getting the right answer? Okay, so let's look at this one. Is 4 to the x plus y equal to 8 to the 10? And I've got x minus y equals 9 and y over x equals 1/4. So first thing I do, I read the whole thing and then I think, what stands out to me? What do I notice? All right, what do you notice as you read? And sometimes I go a little out of order. I might work on a statement before. Powers of 2. Yeah, Gloria sees powers of 2, 4 and 8. Yeah. What else is obnoxious here from our fan of fraction problems? There's something a little bit, a wee bit obnoxious. Stated in a more complicated way than it really needed to be stated. I might even fix this before I went on to try and simplify. Anybody see something a little bit obnoxious? No? You guys don't think? I think this is so obnoxious. Look at this. When they do this, did they have to tell you y over x equals 1/4? I mean, couldn't they tell you, couldn't they do it this way? You know, and make a little, oh, there's my annotation pen, 4y equals x. Wouldn't this be easier to deal with? Did we have to add a fraction just for fun? All right, I mean, the only thing that I know here is that x is not allowed to be 0. Why not? Why not? Anyone? Type in and tell me, why not? Why do I know X is not allowed to be 0. Yeah, it would make it undefined. Okay. So often they would tell me up front, but you know, the GMAT, those sort of people. I know X can't be 0. Again, I'm thinking about the whole thing before I'm starting to work on it. And Gloria saw the powers of 2. So I'm going to immediately, you know, after I've thought about this, okay, there's this obnoxious fraction aspect. Let's see if I can rewrite with the powers of 2. And, you know, this 4y equals x is sort of interesting. Okay, so 4 to the x plus y equal to 8 to the 10. I can rewrite that and say 4 is 2 to the 2. So I want 2 to the 2 raised to the x plus y. Okay, plus, oh no, is this, undo. So I'm going to be just a little slow writing with this because I'm using this new software. Okay, so then I have 8 is 2 to the 3rd. Okay, raised to the 10, and it's a question mark. I don't know that this is true for sure. I'm just asked this. I'm just trying to simplify this darn question. What can I do now? What should I do? Again, I always want to answer the easiest question possible. What should I do? It is data sufficiency. Yeah, it is data sufficiency. And remember, my goal, same base. I got them to the same base. So now let's use exponent rules. All right, 2 to the 2x plus 2y equals 2 to the 30th. Okay. Is that true? Yeah, doesn't that look better? Now what could I do with this? I can simplify this question still further. Okay, and remember it's an is, it's got that question mark at the end. Yeah, okay. I can just say is 2x plus 2y. I would actually, you know, in math terms, I could take the log base 2. And the GMAT gets around saying, you know, because they say, oh, you don't need to know any math as far as logs. You should know that if a base, any base raised to a power, you can't, they have to be equal. There's no way to raise 2 to 2 different numbers and come up with the same number. So this is our real question, which we can simplify one more time, right? Divide by 2. Is x plus 2y, is x plus y equal to 15? Okay. Now, we can look at our statements, our statement 1 and our statement 2. Which statement do you want to do first? You know, and notice how I'm taking my time. I'm just simplifying it. I'm thinking, what do I have in front of me? I'm not worried about an answer yet. What should I look at first, guys? Yeah, let's look at 1. One's pretty simple. X minus y is equal to 9. Now, a really good strategy with data sufficiency, okay, is to see 2 possible approaches. I can either do algebra and try to transform this statement here into this question, or I can just test numbers and come up with an x and a y, x minus y equals 9, and see if I can come up with a case where x plus y is 15 and a case where it's not equal to 15. I can take either approach, all right? Either approach. What approach do you prefer? Algebra or testing numbers? There honestly isn't a right answer, so I'm just asking you guys what approach? Testing numbers and algebra. Okay, so if you're going to use algebra, the fastest way to do this is to say, can I transform the left side here so that it looks like this? And I'll say, okay, fine. I'm going to add y, 2y actually, to both sides, right? Plus 2y. And then I end up with x plus y equals 9 plus 2y. All right, and then the answer is, I don't know. I don't know whether x plus y is 15 because I've got a variable on the other side. So I don't know. All right, that's a super fast way to do it with algebra. You just transform the left side to make it look like one of the sides of the question. And usually the left side of the question is where the variables are. It's sort of traditional from math, how we simplify. Otherwise, I can come up with some numbers, okay? Two numbers that when added together make 15, but when subtracted give me 9. And then two numbers that don't do that. All right, so it's easy to go for a no case. Let's make a little table, x and y. Okay, so I can say x is 10, y is 1, x minus y is 9, check, x plus y is 11. Okay, so that's a yes case. And again, I wouldn't use both approaches. Oh, thank you. Yeah. Yeah, so if we use 12 and 3, 12 minus 3 is 9, 12 plus 3 is 15. All right, so here's my no case. Oops, let me undo this. I put them in the wrong place. Yeah. Okay, so here's my no, because that's 11, and then my yes would be the 12 and 3. All right, how many of you have never done the algebra approach here? I think the algebra approach is really fast. Any of you ever tried this algebra approach where you just transform the left side? It works. In class, we talk a lot about testing, but if you're comfortable with algebra, this approach is very, very fast. Let me know. Have any of you ever tried that where you just transform the left side? Yes or no? Yes? Okay. If you haven't and you're comfortable with algebra, I recommend it because it's so fast. Now, what do I do with the 4y equals x? What do I do with this? Well, okay, so I've got to be careful with substitution. You know, my question is x plus y equal to 15? And if I do substitution, I can force it to be true, right? I can pick an x and I can pick a y so that I force it to be true. And I would just say, well, all right, well, what if x is 12, okay? And then y is 3. I can solve for it, but does that have to be? This is the yes case. Couldn't I also get a no case? William, couldn't I also get a no? Yeah, if I plug in though, there's danger because I think that I'm done. I have to be super careful. I've got the question mark. Plugging in would give me the yes case, but I also need to respect the possibility of a no case, right? X could be 4 and y could be 1. Okay. Yeah, so this is a common trap that people get into. They think that they should plug in. You can plug in if you don't have the question mark. But if you have the question mark, you have to be careful. You can say, okay, well, I could solve to get a yes case. Now, can I also get a no case? Remember, your goal is to try to prove insufficient. Now, and I haven't kept up here, A, D, B, C, E. All right, A and D are out, B is out. Now, is it C or E and why? Think about it. There's a simple reason. Yeah, it's C. Why? I don't even need to do the math. Look at what I have. Here's where I can use a math rule. All right. Two different linear equations. You got it, Dan. Yeah, so why bother to do the math? I'm just going to circle C and move on. All right. So as long as I take my time understanding and I take my time going through the two statements, I don't want to take any more time than necessary. So knowing my rules is very helpful. Tricky things about this problem. Where were they trying to catch you? I think the big thing is this, the question mark. How many of you felt the urge to substitute? Tell me. I know 2 people did, right? I know Daniel did. I know William did. How many of you felt that urge to substitute? You thought, oh, then I can solve, right? We always want to be solving. Anyone else? It's really common. I see it in my classes all the time. Our urge to solve gets in the way of our understanding. All right, I'm going to stop sharing so that I can go on to another problem. Okay. Again, my theme, I think, for tonight has turned into read the question really carefully and slow down, because it's not so much that they're hard. They are tricky, but they're not actually super, super hard. You guys want to do another FDP? Well, let's do an FDP. All right, you guys up for an FDP? We haven't done another FDP, so let's do an FDP. We did that exponent thing. All right, how many people were still thinking FDPs would be nice to see? I have a word problem. And I like the word problem because it's hard, okay, but the issue with hard is that it's hard to understand because you rush. So as we look at it, I want you guys to think with me, what do we do? Okay, can't see answer options, can only see my notes. All right, so did everybody see that last problem that I did? Here, I can flip it back up so you can see it. Let me share my screen for a moment. All right. Share screen, hopefully that's showing it. Okay, and the thing is, right now, what I'm having to do is unshare to go to a different screen. All right, so just be patient with me. FDPs are fractions, decimals, and percents. And what we talk about as FDP problems are often the fraction, decimal, and percent word problems. And the big issue there, again, if you are not rushed and you have time, they often feel easier. They're not really hard math, but they're often tricky to translate, and there's a pretty high error rate for a problem type that shouldn't be that bad. Okay, so let's look at this little beast. It's my last little beast. All right, and you know, again, we're going to take a little different approach than you would in class. In class, you would try to solve it. I want you to look at it and tell me what makes it tricky. Okay, of the land owned by a farmer, 90% was cleared for planting. Of the cleared land, 40% was planted with soybeans and 50% of the cleared land was planted with wheat. If the remaining 720 acres of cleared land was planted with corn, how many acres did the farmer own? All right, anyone getting a headache about now? Well, I don't think it's really an overlapping set, but I do want a picture, Dan. I do want a picture. Is anyone just reading it, me reading it, sort of giving you a headache, like there's too much going on? It's too much to understand? Is anyone feeling that way? Yes, no, possibly? Yeah, a lot to keep up with. So whenever we have a problem where there's really a lot to keep up with, we want to somehow make it easier for ourselves to understand visually. And I like overlapping sets because then we have the double set matrix, right? And I teach stats by day at UT Austin, and you know, I call it a contingency table there, but Manhattan calls it a double set matrix. And my undergraduate stats students love it too for probability problems because it visually makes it visual, makes it simpler. So one of the big things to remember is that we're very visual creatures. So maybe let's make it visual and see if we can, you know, maybe draw something that will help us to deal with this problem. All right, so of the land owned by a farmer, I drew a big rectangle. This is the farmer's land. 90% is cleared for planting. So this is the no plant zone. Okay, no plant. And I have all these numbers here. All right, and I might be planning to test them, I don't know. But this is 90% of, and I'll call it X, right? 90% of the land. Of this 90%, 40% is planted with soybeans. Okay, so the 10% is actually this separate amount. This is the 10% that's the no plant zone. Of the land owned by a farmer, 90% is cleared for planting. So of the cleared land, so we're referring to the 90%. This is the cleared land. Okay. The 10% just seems to have gone for now. 40% is planted with soybeans and 50% of the cleared land. Now, this is where you have to be careful. Yeah, okay, William, you're doing a great job. Okay, so this is 40% of what? And this is 50% of what? Of the cleared land. Yeah, so there's another little sliver here, another 10% of the cleared land. So this is 0.4 times 0.9. This is 0.5 times 0.9. The remaining 720 acres of cleared land. Now we can get an equation for the 720. 720 acres of cleared land equals what? It's 10%. William, 10%. 10%, Anna's saying 10% of the 90%. Yeah. 10% of the 90%. All right. So 720 equals 0.09. Okay, and we want to know how many acres did the farmer own. What can we do with this? 720 equals 0.09. Anyone notice anything that they've done with the numbers to make your life easier? So you don't have to do such beastly math. 72 and 9. Yeah, 72 is a multiple of 9. So I can easily, what if I just divide both by 9? 1% of the land is going to be what? All right, before I do hard labor, I'm always looking for a way out. What's 1% of the land? Well, no, 720 is 9%. So if I divide both sides by 9, right, I'm going to divide by 9. Okay. Yeah, then 80 is going to equal 1%. Okay, now what's the total? Now it's easy, right? Now it's easy. Well, if 80 is 1%, what's 10%? If 80 is 1%. Yeah, if 80 is 1%, 10% is 800, so what's 100%? 8,000. $8,000 equals 100%. Okay, and we found our answer. All right, so notice the way I went slowly and carefully through this problem, really making sure that I understood. And then I looked for something that would help me avoid tedious math. Were any of you thinking that I was going to divide 720 by 0.09? Ugh. 720 is 0.09 of x. Isn't it easier to just divide both sides by 9? And then I can multiply by 100. Yeah. Yeah, and once I've done that, I actually, what do you think? Could I have picked the answer as soon as I did it, as soon as you knew that 1% was 80? Did you really have to do more work? Or were we good to go? Yeah, you're really good to go. You don't want to do more work than you have to if you looked at the answer choices. So the thing that I didn't do explicitly that I should have pointed out, I want you to look at answer choices. Okay? All right, great. Thanks, Erwin. Thanks for joining. Okay, so any takeaways from doing this? What did I do that was maybe a little different from the way most people would do it? And how did that help me get through quickly? Guys, how did that help me get through it quickly? I drew a picture. Yeah, I didn't panic, when I didn't understand. I was visual. I didn't push myself to try to solve before I didn't understand. And I didn't do that in verbal either. I waited until I understood. And this is how you decide whether to bail on a problem. You try to understand it, not to solve it. If you don't understand it, you're not going to be able to solve it. If you can understand it, you can either solve or make a good guess. All right, so it's sort of a switch in mindset, getting away from this idea that you need to push to solve. You actually, what determines whether you'll be able to solve after you've refreshed the content, of course, is your understanding, whether it's quant or it's verbal. And that's why the test seems so much harder when we're taking it under time pressure. Right? How many of you have noticed that you can do those problems if you don't have time pressure? Or you can do a lot more problems. Let me see messages. Yeah, so Gloria, you've taken the class and you're about ready to take your exam. So my challenge to you is to change your approach a little, not to learn more content, but to change your approach and to let yourself take the time to understand. If after a minute you don't understand, guess. Educated guess if you got pretty close to understanding, but if you really don't understand, just let it go. All right, and you'll find that this will really help you both avoid traps. People say, how do I know when to skip? I skip when I don't understand. And help you solve more effectively. You'll have fewer of those problems where you'll go afterwards, oh, why didn't I see that? All right, so we got just 5 minutes left. Is there anything else that you guys would like me to take a look at with you? We did the exponent problem. We did, my friends, the critical reasoning problems. You're welcome, Gloria. And we did an FDP, where we know the math is not that hard, but still lots of people get them wrong. Anything else that I should take a quick look at? I've got 4 minutes. 4 whole minutes. Any overall tips for RC? Okay, so Mike, when I read RC, I make sure I understand as well. And the thing that helps me, I think about, I have a 10-year-old daughter, and I think, how could I explain this to my 10-year-old daughter? Do I understand it well enough? And it particularly helps with the hard reading comprehension, where you might understand the words but not get the real core meaning. And again, try this. If a passage is really hard, you may not be able to do all the questions, but your best chance is in understanding it. All right, so I would say RC is a very similar tip. You struggle with answer choices. Okay, so I would say if you're struggling with answer choices on RC are written to confuse you. Okay, they're deliberately written to confuse you. So what I would say is don't read them until you're pretty sure that you know what the answer is. It's in the passage, and have it in your own simple words and try and see which choice matches. The only type this won't work for is the ones that say all of the following are in the passage except. and then you have to go play a hunting game. In fact, if you have to skip an RC, those are typically the most time consuming and the ones that I would recommend that you skip. Okay, if you're time pressured. So Ashan, how long would I recommend preparing for the exam? It depends on where you're starting and what score you need. If you're starting at a 400 and you need a 720, it's going to take longer than if you're starting at a 600 and you need a 700. All right, so usually what we see in our 9-week class, I see in my classes on average, and I know Manhattan has computed this for me, about a 100-point score move. And I would say, you know, in a class, okay, so if you have a 420 and you want a 650, the first thing to figure out is it content or is it something in strategy, timing, or approach? And I went through a big approach issue here, slowing down and reading it. The way you would figure that out is to go back and review that exam where you got the 420, and does it look like could you do those problems without time pressure? And if you could, it's an issue of approach or strategy. All right, and that's faster to fix. You can move, you know, 230 points very quickly. If it's a content issue, that takes longer because you have to learn that content. And then I would, you know, double the 9-week. I would plan for closer to 4 months. Okay, how often should you do practice problem sets from the OG, and should they all be done on the yellow pad? They don't have to all be done on the yellow pad. And I think of practice problem sets as kind of like working out, you know, to make forward progress. How often do you need to work out? Every week, about 3 or 4 times. Muscle memory, and it's better that they be short workouts, you know, an hour rather than torturing yourself for 4 hours because you won't remember. You'll be so exhausted. All right, William, that would be my recommendation there. You're welcome. Any other questions? Do I recommend taking notes? Ooh, V, that's a great question. Now, I will tell you that I don't take many notes. The only cases where I take notes is where the reading is really dense and I need to force myself to be paying attention and paraphrasing. And then sometimes I will use note-taking to help myself. But otherwise, I prefer that my focus be on really understanding, and I find that if I take notes on easier passages, I'm noting down details rather than pushing my understanding. All right, I think that's a great question. Anyone else? And hopefully I answered. Yeah, we tend to think that there's a magic, that there's a technique, and a lot of this is slow down and understand it. Really understand it. That's how we make our decisions about whether to do the problem or to bail. And that's the single thing that predicts whether we'll get it right. The single best predictor. You are all welcome. You are very, very welcome. Okay, so I'm going to stop the recording. All right, you're welcome, Gloria. You're welcome, guys, and stay in touch. If you want to email me, it's easy, all Manhattan instructors. I'm Moliski at manhattanprep.com. You just use first initial, last name. Let me stop this. Okay. So